We have a 1 kilogram mass is attached to a spring with spring constant 3 newtons per meter. This damping constant for the system is 2 newton seconds per meter. The mass is moved half a meter to the left of equilibrium and pushed to the right at 1 meter per second. So let's set up a differential equation here. The mass is given to us as 1 kilogram. This damping constant, that's C here, that's equal to 2 newton seconds per meter. And K is the spring constant, which is 3 newtons per meter. At time 0, the mass is moved half a meter to the left. So that's why I have a negative 1/2. And is pushed to the right at 1 meter per second. 1 meter per second is a rate, so we need a derivative for that. And that's going to be positive 1. So we need to solve this differential equation by using Laplace transforms. So take the Laplace transform of everything. Now for the Laplace transform of the second derivative, that's going to be s squared times Laplace transform of x minus s times x of 0 minus x prime of 0. The Laplace transform of 2 dx over dt is 2s times the Laplace transform of x of t minus 2 times x of 0. And then Laplace transform of 3x of t is just 3 times Laplace transform of x of t. The Laplace transform of 0 is just 0. Now I want to take advantage of the initial condition. So x of 0 is going to be negative 1/2. And x prime of 0 is 1. So here, negative and negative becomes a positive 1/2. We have a negative 1 here, and then a positive 1 over here. These are going to cancel. Now I can factor out a Laplace transform of x of t, and I'm left with s squared plus 2s plus 3 equals 0. My goal is to solve for x of t, but first, let's move the s of 2 to the right by subtracting. And we'll divide both sides by s squared plus 2s plus 3. At this point, I'm going to factor it out as s plus 1 quantity squared plus 4, and then I'm multiplying by 2, of course. And then split this up into two fractions. The first one is 1 over 2 times s plus 1 quantity squared plus 4 minus s plus 1 over 2 times s plus 1 quantity squared plus 4. Basically, what I'm doing is I'm saying, okay, negative s is equal to 1 minus s plus 1, or 1 minus s minus 1, depending how you look at it. And now I can apply the inverse Laplace both sides. I solve for x of t. And on the right, we have e to the negative t times sine of square root of 2t over 2 root 2 minus 1/2 e to the negative t times cosine of square root of 2 times t. And this is my answer.